I'm feeling better now. Okay.
Good.
What we had to do today?
Friction.
Friction. Have you done anything, everything else?
Yes, I did solved problems for gravity.
Okay. You encountered any difficulty?
No.
Was there any problem? Was there any numerical or any problem or any objective which you could not solve?
No.
Okay. You want to do frictional force today?
Yes, please.
Okay. Frictional force. Okay, I will give you some background of the frictional force, right?
G.
Okay. Frictional force. So first of all, let us know what is a frictional force. What is a frictional force? How it gets created? How it gets created? Number second, about forces, as we know, force is a vector.
Yes.
It must have both magnitude and direction.
Yes.
So after this, we define, we know what is a frictional force, and then we will go to how to find the direction of frictional force, how to find the direction. The direction of frictional force. Direction of frictional force. Is that right?
Yes.
Then, as we know, the force has both magnitude and direction. If we are able to find a direction of frictional force, then finally we have to talk about what's the magnitude of frictional force.
How to find.
Then about frictional force, we can also talk about okay, we'll go ahead and see what we can, how much knowledge we can import.
Yes.
Okay.
Yes.
Okay, that's right. Actually, I was not knowing that you had to do frictional force today. I was thinking that you may have encountered some problems regarding gravitation and projectile motion, or maybe Newton's laws. So I was thinking that I have to solve those problems for you anyway. Now you are interested in frictional force, but you must give full time. You must give a good backup for the concept that we learn here.
Right.
Okay. So, just a minute.
Yes.
Okay. Now, Fatma, you see, whenever two bodies are in contact, okay, let me read out the statement first, and then if I feel necessary to write it down, then I will write it down. When two bodies are in contact and they have a relative motion.
Yes.
They have a relative
motion.
Relative motion means if they rub against each other.
Right.
Relative motion does not mean if both the bodies move in the same direction with the same velocity. That is not relative motion.
जी.
When two bodies are in contact, when two bodies are in contact and are in relative motion,
Right.
then force exists between them. Force exists between them. Exists between them along their surfaces in contact. Surfaces in contact. Called frictional force, right?
Right.
Frictional force. That's all. Now let me explain it a bit. Have a look. Suppose there are two bodies here. This is a body and there is one more body, this. If this moves with velocity v and this moves also with velocity v, there's no relative velocity. I mean, they are moving together.
Right.
Both have the same velocity. They are moving together. Their surfaces are in contact, right?
Yes.
No force. No force. But if its velocity is v2, its velocity is v1, maybe it is 10 meter per second, it is 5 meter per second. This will go ahead and this will recede. I mean, this body is going to recede in the backward direction. Then these two surfaces, they are rubbing against each other. Isn't that?
Yes.
Suppose this is moving faster, this is moving slower. That means this surface is rubbing against each other. And when there's a rubbing here, then there's a frictional force.
Right.
Frictional force. If you put your two hands together, hold your hands and push the folded hands up and down, there's no frictional force. But if you rub your hands against each other, I mean, then there's a frictional force.
Yes.
You can do this practice and put your two hands folded, I mean, put them in contact and push them up and down simultaneously.
So no relative motion.
No relative motion and there's no frictional force. But now you rub the hands against each other, back and forth. Then
Yes.
some heating effect takes place and then there's a frictional force, right? So it is only when there's a relative motion.
Yes.
Is that right?
Yes.
Okay. So this is what you call as friction. Have a look. You see here. Suppose there's a body, surface, earth here, any surface. There's a body here. And the body is moving in the forward direction with any velocity, maybe 10 meters per second. This earth, this surface is at rest. There must be frictional force because the lower surface, this surface, rubs with this surface. This rubbing creates a frictional force.
Yes.
This rubbing creates a frictional force. And there's a frictional force on this body in the backward direction. Although I will give you direction, techniques how to find the frictional force direction, that's different. But here I will tell you, there is a frictional force when two bodies are in contact and those two bodies have a relative motion.
Right.
Okay?
Yes.
Number one. Number second, the frictional force is necessary. It is evil also. It's evil, but necessary. For example, you can't walk on the ground if there's no frictional force. You will slip on the ground if there would have been no frictional force between your feet and the ground. The tire of a car will not roll unless there's a frictional force. You may have observed if there's no friction on the ground, then the tires slip.
Right.
Skid. It is only because if there is no friction. And you may have observed that when there is the tires move on the snow or on the ice, they slip away because there is less friction or no friction. Then the slipping takes place, skidding takes place. Rolling is due to friction.
Right.
Okay. Number one. Number second, The frictional force is so important force, then you can't walk on the ground. If have you observed, because there's a lot of such observations in USA, that if you walk on the ice, on this what you call as on a snow-covered roads or icy roads, then there's a slipping away of the. You have more chance of slipping. You have more chance of skidding on the roadside because
Right.
there's less friction.
Yes.
Is that right?
Yes.
So from these points, friction is very important. And now see, there are space stones coming from the outer space into our atmosphere.
Yes.
It is because of friction. They have a friction with respect to these space stones. When they enter our atmosphere, due to the friction with the atmosphere, they burn and become ashes. The stones, the space stones, coming from the outer space and entering our atmosphere of the earth, if there had been no friction, these stones will come and strike the ground, earth.
Right.
But due to friction, they burn, they become ashes in the atmosphere. That's a good thing. So life cannot survive without friction.
Yes.
You understand that? So these are some positive points of friction.
So is the space rock rubbing against the air to make friction? Is that the second surface?
Certainly, you are right. Spacecrafts also, when they pass through the atmosphere, there's a friction, and there may be some heating effect of the aircraft. But that is not any high velocity. I mean, aircrafts move in this space, but not with that high velocity. The space stones which come from the outer space and enter our atmosphere, they come with a huge velocity. And with that huge velocity, there's a lot of frictional force with the atmospheric molecules. So then it causes burning of these space stones, right?
Yes.
But it is not with the aircraft. Aircraft velocity is very small as compared to that. There is certainly friction. Aircraft may also get heated to some extent, but there is no such danger of burning of the aircraft.
Right.
You understand that?
Yes.
Okay. Now, you see, Fatima, even drilling the hole, if you drill a hole, it is also due to friction.
Mm-hmm.
If you are holding something by your hand, suppose you have a pen, you are holding it by your hand. It is because of the friction between your hand and the pen that holds it.
Yes.
Okay, let me ask you to hold something.
Okay.
It is, suppose it is a fish. Fish. I am very poor in making diagrams, right?
No.
And try to hold the fish in your hand. Between your two fingers, try to hold it.
Mm-hmm.
It is fish, let me suppose you are trying to hold it, right?
Yes.
It will slip down. It will slip down. Try it. Because there is less, it is slippery. This fish is slippery and it will slip down. You can't hold it. So if you are holding something in your hand by your fingers, that is also due to friction.
Mm-hmm.
Sometimes you may have to, you see, even if somebody has to pull up his teeth, maybe sometimes somebody has to pull out his teeth because of some problem in his or in her teeth, in her tooth. That is also by friction. When you see, if you make a good grip, good hold on something, it's only due to friction.
Mm-hmm.
Do you have a little bit of feel of friction?
Yes.
You see, when these wrestlers, when the wrestlers go to the wrestling site and they massage themselves by oil,
Right.
so that they are not able to catch hold of each other.
Yes.
They become slippery and they are not able to catch hold of each other because they reduce the friction.
Yes.
If somebody holds somebody else by neck, It is only friction that can hold his neck. So friction is very important thing for the for life going on smoothly, right?
Yes.
Okay. Now friction is bad also to some extent. Why? Because you see, this frictional forces creates heat. If you rub your hands, heat is generated. And in the mills and the factories, you see, if there's a frictional force, you had to use oil, you had to use some grease, you had to use certain those ball bearings between, so that sliding becomes easier. If suppose you have to slide these two bodies against each other, if they are in contact, friction will not allow them to slide so easily, and therefore you separate the two bodies by ball bearings, or by oil, or by grease, or by something, that friction is reduced. Why we do that? Because friction always creates heat, and heat is a form of energy. So frictional forces always try to drain out energy from the system. Whenever frictional forces are operating in a given system, then that system loses energy all the time, because it produces heat. So there, what we do, we try to reduce friction. We try to reduce friction.
Right.
That is why we call it as a necessary evil. Necessary it is, evil it is in some cases, because you see, it reduces energy, because it produces heat all the time.
Yes.
Is that right?
Yes.
Do you understand it slight? Do you
Yes.
now get some slight understanding of the frictional force, right?
Yeah. So like so factories, we always have oily or greasy lines, or like whatever machinery, so we can reduce the friction.
Yes.
And so most energy is conserved for.
That's right. That's right. You see, here in our case here, we have those sieving machines.
Yes.
They need a lot of oiling to reduce friction. Sieving machines, the machines all use oil to reduce friction, because if we don't use oil or anything else to reduce friction, these machines get heated up due to frictional force. Is that right?
Yes.
Okay. Now, the second point is that how to find the direction of the friction force. How to find direction of frictional force. Okay. Suppose, you see, there are two techniques to find the direction of friction force. Two techniques. Number one technique is, which I will explain you. You see, let us take, okay, a body here. And you are applying force, right?
Yes.
What is this force? This is the applied force.
Force applied. Yes.
You are applying force F. You are pushing this body, na? Mass M. Is that right?
Yes.
How much force you are applying?
However much to overcome frictional force.
No. You have to answer my question, na?
Okay.
How much force you are applying?
In N? Newtons?
How much force I am applying? Yeah, you are applying to the body.
mg.
F.
Or F equals.
mg is downwards.
Oh, right.
That has been balanced by the normal reaction. That's not the concern. Downward and upward force, they have balanced each other. So you don't need to bother about that. It is this force which you apply.
Right.
Okay. Now, there's a friction between this body and this body. Lower body is surface, any surface. Maybe it is a table, maybe it is the ground, maybe it is something horizontal, and there's a body on it, and you apply this force to this body.
Right.
Is that right?
Yes.
Okay. Now see, tell me, there is friction, of course, but if for a moment you just ignore,
Okay.
you just feel in your mind there's no friction.
Right.
Suppose you feel there's no
Friction.
where will the body will go?
It will stay moving at whatever velocity it initially is at.
Okay. It will go in this direction.
Okay.
So if you forget about the friction, the body will go in the forward.
Forward direction.
The frictional force is backward. That's all.
Mm-hmm.
So what you have learned? You have learned you have to forget the friction and watch the tendency of motion of the body. The frictional force is against the tendency of motion.
Right.
You have to put it in your mind first.
Frictional force goes in the opposite direction of force applied.
That's not always there, but the technique is if you apply a force and had there been no friction, what was the tendency of the motion of the body?
Forward.
Forward. Because had there been no friction, the body will move forward. Friction force is opposed to that.
Okay.
Opposed to that forward motion.
Right.
Is that right? But first of all, you have to forget that there is friction and watch the tendency of the motion of the body. The friction force will be opposed to that tendency.
Right.
I will give you many examples so that you understand. Okay. See, here is an inclined plane. Body is here.
Any mass.
Right?
Yes.
Had there been, okay, the body is at rest. The body is just on the incline, it is at rest. It does not fall down.
Mm-hmm.
And you must know who holds it there.
Friction.
Yes, certainly. Suppose it would have been this triangular shaped incline, it would have been made of ice. And this would have been ice cube. Do you think it will stay there?
No.
It will go down, right?
Yes.
So if it is there, it is because of friction.
Right.
Now, what's the direction of friction force?
Direction of frictional force.
Yes.
Well, its tendency is to move down the slope, so frictional force would be trying to hold it back towards the top of the
That's
slope.
good. Now, see, that's good. Yeah, you have given me the right answer. Imagine there is no friction. It is an ice here. It is ice here. While the body will go
Downwards.
So you have to feel. So what do you have to feel? You have to feel there's no friction, and immediately no friction means it will go
Downwards.
down. So friction force is upwards against that tendency. So
right.
You see, there's a technique. Imagine there's no friction.
Mm-hmm.
Imagine there is
no friction.
No friction. Second, feel the tendency of motion.
Right.
Tendency of
motion.
And third, friction is opposed to that tendency. Friction is opposite to that tendency. You know the technique now. You see, I will repeat these 3 steps. I will repeat it again here. Imagine there's no friction. Okay?
Yes.
Imagine there's no friction.
Mm-hmm.
What is the feel the tendency of motion? Where it is?
Down.
Down. Friction is opposed to that tendency. Finish.
Yes.
Maybe you already know the direction of frictional force. I don't doubt that. But this technique will make it foolproof. You will not make any mistake in finding the direction of frictional force. Okay.
Yes.
Okay, one more example. One more example. See here. It's a truck. And here, I don't know, here's the driver moving the truck in the forward direction. And on the truck, there is an object. What is the frictional force on this object when the truck moves in the forward direction?
Just enough to keep it on the truck's bed. If the truck is moving in the forward direction,
Yes.
it just needs to stay in the truck. So the surface between the object and the floor of the truck,
Yes.
is where the frictional force will be. So that
okay, give me the direction.
direction.
Forward, sir, forward.
American yes. What is the direction of the frictional force?
Backwards? Towards the back?
No. See, you are knowing the concept. You see, you uttered a word which struck me. You uttered a very nice word. You said when the truck moves forward, this object needs to remain in the truck. So that force will take it along the truck. Forward force. No? Unconsciously. You said unconsciously that it needs to remain in the truck and it needs to go forward.
Right.
So see here how the technique works here. Imagine there is no friction between the truck surface and this object. The truck moves in the forward direction. It will slip. If there is no frictions,
it will slip.
Suppose there is an ice layer on this surface and it is ice cube. The truck moves in the forward direction. What will happen to this ice cube?
It'll slip backwards. Its tendency to move is towards the back.
It will slip backwards with respect to the driver.
Right.
Had there been no friction, it will slip backwards. So friction force is forward.
Yes.
And you already said that it needs to go forward. Therefore, friction force has to be forward. So here, generally, students make a mistake that the truck moves forward, friction is backward. That is the wrong concept, right? So here the student starts making mistakes if he does not have a clear concept of the direction of the frictional force, right?
Yes.
Okay. Okay, I will give you one more example. This is a body here. This is one more body here. This is one more body. Okay, this is one more body. This lower body moves with velocity v. Tell me what is frictional force on this body, and on this body.
Okay, velocity.
Okay. Just a minute. Take your time, a minute, and give me the answer.
Okay.
Take your time.
The body immediately above the first
body. It is second body, it is third body, it is fourth body. What is the direction of frictional force on the second body?
For second body, frictional force is forwards.
Absolutely right. But how you came to know about it?
Because I was imagining that it's like a cart, and then the top three is like a cake. So
okay.
The cake is backwards.
Okay.
Right?
Can you tell me what's frictional force on the lower body is?
Lower body's frictional force is backwards.
Good. How do you know that? I will tell you that. I will make easier things for you. These are two bodies. If you find frictional force on one body, on the other body it will be opposite, because to every action there's equal and opposite reaction. These are two bodies. If on one body there's a force forward, on the other body there will be backward. So there's no problem that way, because if you have to find frictional force only on one body. Okay. Now, can you tell me what's the frictional force on this body?
On the second, number 3.
Third body.
Third would be backwards.
How you came to know about that?
Because the one for number 2 is going forward. So if we're doing the equal and opposite reaction,
No, action reaction is between these two, because force on this and force on this is action reaction pair.
Okay.
If now this body creates force on this body, it is reaction will be on this body. There will be again two forces, this and this, but they will be different from these two. Now see, this F1 force is on this second body, and this F1 will make the second body to move in the forward direction. So it will accelerate in the forward direction. Had there been no friction, what will happen to this body? It will go in the forward direction. What will happen to this body had there been no friction between this and this? अगर friction नहीं होता तो क्या होता है इस body का?
Slip away.
Slip away. It will slip away. Its friction force is forward. Slip away means it will go forward. This will go backward with respect to this had there been no friction.
Right.
And what is frictional force? Is frictional force F2 is here on this. What is on this body?
Minus F2 or just F2 in general?
Is per F2 forward and on this F2 backward. So tell me now, what's frictional force on this between these two surfaces? F2 force on this body will make an acceleration in the forward direction. So it will move in the forward direction because of this force.
Right.
And that force will accelerate it, and that force will give it velocity in this direction. So had there been no friction between this and this, it will slip away.
Right.
So its force is F3. And its force will be backward F3. So it is action, it is reaction. It is action, it is reaction. It is action, it is reaction. So if you use a right technique to find the direction of frictional force, only then you can find direction of frictional force. It is very tricky. Sometimes even an experienced person will fail to find the right direction of a frictional force.
Right.
Is that right?
Yes.
Okay. Now, should I give more examples?
One more.
One more? Okay.
Yes, please.
I will give you one more example. This is a body. It has velocity 10 meters per second. This is one more body. This has velocity 2 meters per second. What is frictional force on this body and what's frictional force on this body? Okay, you find frictional force on only one body. Not on two bodies, because on the second body it will be opposed anyway. Give me the answer.
First one is moving faster, so its tendency is to move forward. So the frictional force is backwards on the first body. The above body.
On this body, will it be backward?
I believe so.
Will it be backward on this body?
Yes.
That is right. On this body?
So this one's gonna move backwards, so its frictional force is forward.
That is right. But which technique you use here?
I first saw which way it's gonna move.
That is right. What you did, I think, had there been no friction between this and this?
Yes.
Had there been no friction this and this, this will tend to go in the forward direction with respect to this because it is faster.
Yes.
This will tend to go
forward direction.
in the forward with respect to whom?
Right.
Lower body. This is moving lower velocity. This is higher velocity. So it will move. it will exceed this body in motion. It will go forward with respect to this. ये आगे चला जाएगा ना?
जी.
Had there been no friction, therefore frictional force on this will be backward.
Yes.
And here, obviously, you don't need now to apply your mind, or you don't need to apply any technique or even exert your mind to find the friction force on this body. It is just, if F is backward, this is forward.
Right.
Sometimes what you use is, to every action there is equal and opposite reaction.
Right.
So you don't need to apply and exert your mind in every case. You have found the frictional force this, and then it is automatically forward because of this. Do you understand that?
Yes.
Now, should I give you one more example, or it is now sufficient for you to find the direction of friction force?
I think I understand now.
Can you understand now?
Yes.
That's very nice. That's very nice. Okay. Now, should we go how to find the direction, how to find the magnitude of frictional force?
Yes.
Or should we do it tomorrow?
I think we can save it for tomorrow.
Okay. I'm also not feeling well today. I'm not quite well, although I have recovered to a better extent, but now I'm not fully recovered. I'm not fully recovered. So let it be tomorrow, right?
Okay. Make sure you sleep a lot and rest.
I will try today. I will try to sleep.
आप बहुत लेट सोते हैं.
मैं हमेशा 1-1:30 बजे सोता हूँ.
Oh my god. Oh no.
It is my usual timing. Anyway, at this age, at my age, one cannot sleep for long hours.
Oh no.
Okay.
जी.
Best of luck.
Thank you. Allah Hafiz.
Allah bless you. Allah Hafiz.
Allah Hafiz.